In the walls and gates problem, you are given a two-dimensional grid where each cell can be either a gate represented by a 0, a wall represented by a -1, or an empty room represented by infinity, which will store as 2 to the power of 31 minus 1. You are asked, given such a grid, to find out the distance for every empty room to the closest gate. Intuitively, from the first empty room, we would need 3 steps down to reach the closest gate. From the next one, only 1 step to the left. From the next empty room, 2 down, and from the next one, we can reach any gate in 3 steps. There are 2 things that make this problem tricky to approach, and the first one is recognizing that this is a graph problem. We can treat our grid as an undirected graph where each cell is a node. In an undirected graph, we have 2 main approaches to traverse it, either a depth first search traversal or a breadth first search traversal. When a problem asks to find the shortest path to something, like in our case to find the closest gate for each empty room, then it's most likely asking us to implement breadth first search. The core idea of our approach will be to loop through every cell of the grid, and whenever we find an empty room, we launch a breadth first search and store the result in that cell. Now, the way breadth first search is typically implemented is with the help of a queue. At every step we pop an element out of the queue, and the neighbors that can be visited are added to the queue. If at any moment one of those neighbors is a gate, we break the execution and return the result. You might notice that when we are looking at the neighbors, there are a couple of blocks of code here that are very similar. So what we can do to tidy things up is to use a directions array and loop over those directions. The second thing that makes the problem tricky is recognizing that rather than launching a breadth first search from every empty room, we can launch a single breadth first search that initially contains all the gates in the queue. Because breadth first search expands in layers, the first time we visit a room is guaranteed to be the shortest distance from any gate. That's it for this video. See you in the next one.